Today we're looking at the humble spark plug. Now this guy, I don't reckon, gets the attention that he deserves. He's no suit and tie kind of guy. He's not like the rest of the ignition system that gets all the attention. No, he's a blue collar worker just like you and me. Not meaning to demean him, but in reality he's just a gap that allows the high voltage from the ignition coil to jump. But in all fairness, he works in some of the harshest conditions in the engine itself. Extreme heat, surrounded by carbon, oil fumes, fuel fumes, stinky hot environments. Who'd want to be there? Sounds like a mechanic. The spark plug has to work in really harsh conditions. In fact, there's extreme turbulence right inside the cylinder that can put out its little tiny flame before it's done its job. And then there's the pressure. Oh, the pressure! While our little spark might fire out here in the atmosphere, inside the cylinder it's under extreme pressure, and that makes it even harder for the spark to fire. Think about it, during a cranking compression test you're going to get about 150 to 200 psi, something along those lines. So imagine the pressure on the little spark plug and the flame to try and put it out. Harsh conditions. Did you know that air is actually very high in resistance, and that makes it even harder for the spark to jump across that gap? And when there's extra load put on the engine, or there's a lean mixture, which means there's more air than there should be, it makes it very, very difficult for that spark to fire. That's why the coil and the spark plug and anything in the secondary, or the ignition system for that matter, must be in top condition. So what's the actual construction of a spark plug, and how does it do what it's got to do? Spark plugs come in a variety of shapes and sizes, and they're designed specifically to meet the needs of the engine that it's fitted to. You can see some have a short reach, some have a long reach. Others have a multiple earth electrode. So what's inside a spark plug? Here's one I made in AutoCAD some years ago. It gives you an idea of the internal construction, but let's pull it apart further. Starting at this side, we have what's called the terminal nut. You can see the ribs here on the insulator, which are designed to hold the spark plug boot. This insulator is forced into the threaded nut here, and the insulated end here is exposed just the right amount out here to give us the correct heat range. We have a ground electrode off to one side here. Down here we have a washer, but some configurations can include just a tapered seat. On most spark plugs nowadays they're called a resisted spark plug. The reason is, yes, they have a little resistor just down in here. This here is the center electrode, and you notice that it has a copper core in this particular case. And when we stick it all together, we get something like this. Each spark plug has a name written on it, of course, and that confusing code. Now that code tells you the design and construction of the spark plug and what it's used for. Here, for example, is an NGK spark plug, as you can see. So the code starts with BK. If we have a look at the NGK website here, you can see that BK represents 14 mil. Now that 14 mil represents the thread size in diameter across here, and the hex or the nut size is 5/8 or 16 mil. Our next number there says R, which, as you can see here, indicates that it's a resisted spark plug, or it's got that little resistor stuck in the middle for suppression of EMF, or to stop noise, or radio as well as electronic components. Next up is the number 5. Over here that represents the heat range, so that's within a hotter range, a hotter type of spark plug. I'll explain what that means shortly. Next on our list is the letter E. That defines the reach, and you can see E represents 19mm reach. In other words, how long or how deep is this thread? Next up is KB. While it's not actually listed on the site here, we can see something similar, KC or KUB, and that refers to having 2 ground electrodes. That's these guys here. Other spark plugs, as I mentioned before, just have 1 earth electrode. And finally underneath you can see the number 11. 11 represents 1.1mm gap, or 44 thou, which means that you don't adjust the gap on these type of spark plugs. For example, you can clearly see the difference between these 2 spark plugs. The thread diameter is clearly different, and including the reach. This here is 19 mil, this one over here is about 26 mil in reach. This bloke over here is designed to be used for direct injection. The reason that it's so skinny here in the thread size compared to this fella over here is that we're running out of real estate in the cylinder head. Keep in mind there has to be an injector over here as well. There's just not enough space. And of course it has to go through all the head thickness as well, and so that's why it has a deep reach. You may have seen this before as well, platinum, and that's to do with the electrodes. Sometimes it's just referring to the center electrode here. Other times, if it's a double platinum, it's referring to a tip, a tiny bit of platinum that is welded onto the earth electrode, as well as a tiny bit of platinum that is welded onto the center electrode. It lasts a lot longer than just your standard style of spark plug. While they say these should last about 100,000 Ks, in fact it's a good idea to replace them a little bit before that, perhaps 80,000 Ks. You might have noticed when I was turning this around there was some black lines down here. Are they okay or not? No, that's called tracking. I have several here that show that indication, and it's not a good thing. Obviously the spark plug has failed internally, so much so that the high voltage going down the center electrode here finds an easier path to go down past the insulator onto the earth nut. Keep in mind this tracking can continue through to the cylinder head if it's a plug over system, or it can damage your plug leads as well. A new spark plug will have a nice flat edge on the center electrode, as you can see there. But given time, they just wear down like any metal part. You can see that center electrode is quite rounded, isn't it? Time for this fella to be replaced. These guys work in really harsh conditions. The computer controlled fuel burn modes include homogeneous, stratified, homogeneous lean burn, homogeneous stratified charge mode, homogeneous anti-lock, stratified charge catalyst heating. Poor little guy, he's got a really tough job. The heat range indicates the ability to dissipate heat, and that's the relationship between the insulator here and the nut position, and how it can dissipate heat through the cylinder head or through other areas as well. The Champion range uses a heat range that goes up in number. For instance, this is number 9, that's a colder plug than this fella over here, which is number 12. This is a hotter plug. Whereas the NGK range work backwards. The number 5 indicates that it's a hotter plug, and as the numbers go up, they indicate that they get colder. Number 6, you got a colder plug. So if you go onto each manufacturer's site, you're able to see the coding and what that represents. Apart from a spark plug just being plain old worn out through excessive use or time, there's other conditions that can cause spark plugs to fail. For instance, incorrect gap. You can see this one's been mechanically hit, maybe by a valve or a piston or some other reason. That's going to create a short. Excessive gap set by the mechanic when fitted. Don't think this fella's going anywhere. Excessive carbon build-up. Obviously it's burning oil for some reason, and that's going to create a short. And as mentioned, this tracking that we see down here, it creates a path from our positive right down to our nut here, off to earth, and that creates a short in the spark plug as well. But notice something else. See this little colour here, this orange looking colour? Don't panic. It's called coronal flare. That's where ionised particles are able to jump around. If you run a vehicle at night and have a really close look, sometimes you can see a purple glow around this area. And that's just because of oil particles, other things that create a little glow down there. It's not an indication of a faulty spark plug, and it's not an indication that you're not getting a good spark here. While most of the spark plugs that we deal with nowadays do have a preset gap, remember that number 11, that represents 1.1 millimetre. But there might be instances where we actually need to adjust the gap of the spark plug. How do we do that? This is actually the correct tool that you use to adjust a spark plug gap, but I'll be honest, most of us just use feeler gauges. By means of these little teeth here, you can actually pull the earth electrode back and open up the gap a little bit. Just be careful not to damage the insulator there, and you can check it with the measurements here. So in this case, I'm just going to use the 40 thou one. Looks like the other one's been broken off at some point. So just sliding it between the positive and the negative electrode, or the earth electrode, it should have quite a nice drag on there. You can see that there's quite a gap, and all you have to do is just gently belt it on something that's metal, making sure that you don't do it excessively until you get the gap that you want. You can see now it's dragging a little bit, fraction more. Perfect. Nice. Okay, so that's how you adjust a spark plug gap. But of course you'd have to look up the manufacturer's specs to find out the exact gap for your application. Now that we've learnt about spark plugs, their design and some of the conditions that they have to experience, how do we test them on a vehicle? How do we make sure that they're doing the job that they're designed to do?